Hi. So far we have solved many problems in Fourier series in the interval 0 to 2 pi and minus pi to pi. Also from the last video we have started arbitrary interval, that is 0 to 2l and minus l comma l. And also I explained about the process of finding l and how to check even or odd in those intervals. So today in this video we are just going to continue problems in arbitrary intervals to get more idea about it. So consider this problem: f of x is equal to x minus x square in the interval minus 1 comma 1. So as I told you, when we are going to compare this interval either with minus l comma l or 0 to 2l, right? Doesn't start with 0, so it is similar to minus l comma l. So in the place of L, it's very obvious, it's 1. So L is equal to 1 in this problem. We fixed L. Now we have to check whether the function is even or odd in the given interval, because if the function is even, then Bn becomes 0, so no need to find Bn. If the function is odd, A0 and An is going to become 0. And since the interval is minus L comma L, what is the regular checking procedure in minus pi comma pi or minus L comma L? We'll replace x by minus x in the given function. If we get the same function back, then the function is even. If we get a negative of that function, then we call that function as odd function. So we are going to replace x by minus x. So in the place of x, replaced minus x minus x the whole square. Since minus x the whole square, it is nothing but plus x square. This minus is there outside. So we have minus x square. We can take minus common, x plus x square. So this minus of x plus x square is not equal to x minus x square, as well as negative of x minus x square, because minus of x minus x square means minus x plus x square. So this is not equal to minus x plus x square, and this is not equal to x minus x square. It means the function is neither even nor odd. Already I have told you, if the function is neither even nor odd, then it's like a normal problem. You have to find all the values a0, an and bn. And also we have an option: if you are not able to identify whether the function is even or odd, no need to make this statement, it's neither even nor odd. We can just start solving by writing the formula. What is the general formula? F of x is equal to a0 by 2 plus summation n is equal to 1 to infinity an cos n pi x by l plus summation n is equal to 1 to infinity bn sin n pi x by l. This is a formula. So we have to find a0, an and bn. So here no 2 into integral only 1/2 will not come into in this problem, because the function is neither even nor odd. So we are going to integrate in the interval minus 1 comma 1. So if you see here, the formula a0 is 1 by L integral minus L to L f of x dx. This is the general formula. In case if I say that this function is going to be an even function, then in that case bn only will become 0. What we will write the formula is 2 by L integral 0 to L. That is the difference. You got it? So since the function is neither even nor odd, we are going to use the normal formula. So 1 by 1 integral minus 1 to 1. The function is x minus x square dx. Simple integration. Integral of x is x square by 2. Integral of x square is x cube by 3, and we are going to apply the limit minus 1 to 1. So first we will apply upper limit. So 1 by 2, and then we will apply lower limit minus 1 square, so it is plus 1 by 2. So first term will become 0, then again second term, outside minus sign is there, upper limit 1 by 3 minus 1 the whole cube. Since it's an odd function, so we will get negative sign over here. This minus and this minus will get plus, so you will get some value for a0. In case if a0 alone becomes 0, so don't get confused thinking that okay, a0 should become 0 only when the function is odd. No, it is not. Sometimes a0 can become 0. It's just a constant, right? Instead of some other constant, it could be 0, and an value you will get it. So now we have to find an. An is 1 by L integral minus L to L f of x cos n pi x by L dx. So 1 by 1 integral minus 1 to 1 x minus x square is your given function in the question, cos n pi x by 1 dx. Here it's easy, there is no fraction kind of thing, or nothing is there in the denominator since L is 1. Of course we will see problems when L is 2 by 3 or 3 by 2. And if there is a multiplication in integration, then obviously it's Bernoulli's. In Bernoulli's, which term we will differentiate? The term that's going to vanish after differentiation. So cos will not vanish, right? Cos will become sine, sine will become cos, and so on. So which is going to vanish? X minus x square is going to vanish. So as I told you in Bernoulli's, what you have to do? First do only differentiation. So write x minus x square. Leave some space. Don't think about integration now. Put a negative sign because signs are alternate. First is positive, second one is negative. Differentiation of x is 1, differentiation of x square is 2x. So we'll get 1 minus 2x. Then put a positive sign. You're going to differentiate what is there inside the bracket. Differentiation of 1 is 0, minus 2x is minus 2. Written here. Now coming to integration part. So here we will not write cos. First we will directly integrate. Okay. Here we will write the function and then differentiate. Signs are plus, minus, plus, and so on. Here there is in this term cos n pi x, if you integrate sin n pi x by n pi. Already 1 n pi is there. We are carrying it here. Again sin n pi, if I integrate, it is minus cos n pi by n pi. That n pi and this n pi will become n pi the whole square. In the next step, n pi whole square into 1 more n pi, it will become n pi cube, and cos n pi integration is sin n pi. It's positive only. This negative sign I am just carrying it to the other one. It's like we are just doing integration, and already existing 1 by n pi we are carrying here. Here minus 1 by n pi square we are carrying to the next step. That's it. So now the next step is we have to apply the limit minus 1 comma 1. So whenever we are applying the limit, just see the concept here. Here there is no fraction luckily. So if I replace x by 1, I will get sin n pi. If I replace x by minus 1, I will get minus sin n pi. Whether it's plus or minus, sin n pi is going to be 0. So this term will become 0. Again last term also will become 0. Only you have to apply limit for this term. Okay, this minus and this minus will become plus, and if you apply the upper limit, we will get cos n pi, and if you apply the lower limit, cos n pi of minus 1. So what is the formula? Cos n of minus theta is nothing but cos n theta, correct? Cos of minus n theta is cos n theta, because the function is an even function, so we will get cos n pi when we are applying the lower limit here. And then here 1 minus 2 into minus 1. 2 into minus 1 will become this minus, and this minus will become plus, so 2. Other things are, oh my god, this is not visible. One second. Yeah. So this is what I was talking about. So we will apply upper limit here. 1 minus 2 into 1. You will get this cos n pi. And then when you are applying lower limit, cos n pi into minus 1 is nothing but plus cos n pi. This negative sign is lower limit. Before applying the lower limit, we will write, right, upper limit minus lower limit, that negative sign. And again 1 minus 2 into minus 1, so it will become 1 plus 2. That's what I explained. And then it's just simplification. And after simplification, we get this minus 1 power n by n square pi square into minus 4. This is the value for En. We are yet to find Bn. See, if the function is neither even nor odd, you have to find all the values a naught, an, and bn. So that is why always checking even or odd in the beginning, that saves your time. But still, in the examination, as I told you, don't get confused. If you cannot decide whether the function is even or odd, you can start solving directly. So Bn is same, 1 by L integral minus L to L f of x sin n pi x by L, just substituting the formula. Now I think you can do the Bernoulli's on your own. First write x minus x square, negative sign, differentiation of x minus x square you are writing, plus positive sign, differentiation of 1 minus 2x you are writing. Sine integration is minus cos, cos integration is sine, sine integration is again cos. Same. Limit is minus 1 to n, 1. Which term will become 0? Sine n pi. So this term will become 0. You will get limit for this term and this term. Substitute the limits carefully. Upper limit, that is wherever x is there, replace 1. That is upper limit, minus lower limit. Wherever x is there, replace minus 1. And I'll leave the simplification part to you because so far we have done almost kind of 20 problems close to in this Fourier series. So I just want you to simplify on your own and you will get this. Because simplification takes more time, so give more step to avoid mistakes. And after finding Bn, finally you are going to substitute in the formula. F of x is a naught by 2. So this is a naught by 2 plus summation n is equal to 1 to infinity a n value. So we got that as minus 4 into minus 1 power n by n square pi square cos n by x plus summation n is equal to 1 to infinity Bn sin n by x. So this is a solution, and we have discussed a problem neither even nor odd. Actually it is a continuous function, right? Continuous function in minus L comma L. And here comes another problem, and you can see obviously it's an arbitrary function. Of course this is also in the interval minus L comma L, but it's a discontinuous function because from minus 3 by 2 to 0 we have this function, and 0 to 3 by 2 we have another function. But to find L, what we'll do, we'll write first value and the last value and we'll check. What is the first value? Minus 3 by 2. What's the last value in the interval? 3 by 2. So we are going to compare minus 3 by 2 comma 3 by 2 with minus L comma L. Okay. So yes, you can see minus L comma L. So it's same as first value I have written minus 3 by 2 comma 3 by 2. So what is L here? 3 by 2. So we got a fraction here. We have to be very careful in integration and applying the limits also. So we got L as 3 by 2. Great. Now since the function is discontinuous, first function we write it as f1 of x, second function we'll write f2 of x, and checking even or odd procedure. What is even or odd procedure in minus LL? We will replace x by minus x. Previous problem we did in continuous, right? So here slight change. It's like I will replace x by minus x in the first function. If I get the second function, then the function is even. If I get negative of that second function, then the function is odd. If I am getting some other new function, then it's neither even nor odd. So I'm going to change x by minus x in the first function. 1 plus 4 into minus x by 3. 1 plus 4 into minus x by 3 is nothing but 1 minus 4x by 3. Hola, we got the second function f2 of x. So the function is even. So what's the happy news? If the function is even, no need to find Bn. Bn will become 0. Good. At least now we can find only two integrals, that is a0 and an. What is the formula for a0? 2 by L. Remember, once we declare the function is even, we will not completely integrate from minus L to L. So I am saying anyhow this function is even. Why I have to waste time in finding the entire thing? I will find only for 1/2, 0 to L, and multiply by 2. Okay, and remember in the previous one we wrote 1 by L integral minus L to L because the function is neither even nor odd. So 2 by L integral 0 to L f of x dx. 2 by L is 3 by 2. If it comes to the numerator, this 2 will come here in the numerator, so 4 by 3 we will get. That's what we have written in the next step. And my function is in 0 to L. That is 0 to L. Here it is. What is my function? 1 minus 4x by 3. We will not use this function at all, 1 plus 4x by 3. So please be careful which function you are going to write. So in 0 to L, that is in 0 to 3 by 2, my function is 1 minus 4x by 3. So we have written only that. Integration of 1 is x. Please don't write it as 0. It is nothing but integral 1 dx. So integral of dx is x. Differentiation of 1 is 0, but integration of x dx is x. Minus 4 by 3 into x integration is x square by 2. What is the limit? 0 to 3 by 2. Okay. So 4 by 3 is here, and just we are going to apply upper limit minus lower limit. And here, before applying the limit, you just check. I'll get upper limit for this term. I'll get upper limit for this term. What about lower limit? Second term will become 0, because x, when I substitute x as 0, this will become 0. So I will get only upper limit for these two terms. So if I substitute x as 3 by 2, I'll get 3 by 2 minus 4 by 3 into x square by 2. So x square is 3 by 2 the whole square. And yeah, we have just substituted the same thing. Now after taking LCM and simplification, we got a naught as 0. Just now I've mentioned the previous one, right? Bn is 0. So don't think that a naught will become 0 only for odd function. A naught is just a constant. You will get an also. Okay. So now you have to find an. Yeah. So 2 by L, integral 0 to L, f of x cos n by x by L dx. Here you are getting L. In the last problem L was 1, so it's easy for you. So function f of x in 0 to L is 1 minus 4x by 3, same. And cos n pi x by L is 3 by 2. So your function is 2 by 3 n pi. This is like the whole constant value into x dx. So what's the constant here? This 3 by 2, this 2 will go to the numerator, 2 n pi by 3. So it's in multiplication. Obviously Bernoulli's. Which term will vanish after differentiation? So this term. So this is going to be u. I'm going to differentiate this term and integrate this term. Same Bernoulli's. Here comes the integration part. First of all, don't get confused. Just write things neatly. It's more than enough. So what we are going to do? First we are going to write 1 minus 4x by 3. Don't think about other term. Leave it. Leave some space. Put a negative sign. 1 differentiation is 0. Minus 4 by 3x. We'll write only the constant. Minus 4 by 3. That's it. Next term, differentiation of minus 4 by 3 is constant. Differentiation of constant is 0. So there is no next term. Okay. And cos we had. Cos if I integrate it will become sine. Sine 2n pi by 3x. What is the constant? 2n pi by 3. We'll divide it by constant. That's it. Sine 5x, if I integrate sine 5x by, cos 5x if I integrate, I'll write sine 5x by 5. In the place of 5, the constant we have 2n pi by 3. We are just dividing with that constant. That's it. And sine integration again is minus cos. So minus cos 2n pi by 3x divided by 2n pi by 3. Already 2n pi by 3 is in the previous step, so we have written whole square. And then we have to apply the limit 0 and 3 by 2 is the upper limit and 0 is the lower limit. So what will happen if I apply 3 by 2 for this term? I will get 2n pi by 3 into 3 by 2. Like this it will come. 3 and 3 will get cancelled, 2 and 2 will get cancelled, and you will get only sine n pi. Sine n pi is 0, and then if I apply lower limit in the place of x, sine 0. Sine 0 is 0. So automatically this term will vanish. This term will become completely 0. Because I am replacing, can you see this sine 2n pi by 3 into x. I don't care about the denominator, it's just a constant, leave it. Only check the numerator. So you are going to replace x by 3 by 2. Already constant is 2n pi by 3 into 3 by 2. So this 3, 2, 2, everything will get cancelled. I will get sine n pi. So sine n pi is 0 and sine 0 is 0. So this term will become 0 out of 2 terms. Only you have to apply limit for this. Don't even simplify this. Anyhow, it's going to become 0. So now concentrate only in this term. This minus and this minus will become plus. Okay. And If I square this, 3 square will come to the numerator. That 3 square and one more 3 is there here. That will get cancelled. And denominator we have 4n square pi square. Again the 4 will get cancelled here because of one more 4 is there outside, right? So that will get cancelled. So we have 3 only in the numerator since 4 gets cancelled. 3 by n square pi square. Negative sign is there. If I apply the upper limit, again 2 by 3 and 3 by 2 will get cancelled. Here in the place of x, if I replace 3 by 2, 3 by 2 and 2 by 3 will get cancelled. Only I will be left with cos n pi. Similarly, if I apply lower limit, cos 0. Though the problem looks so big here, all of a sudden it will shrink. That is the advantage in Fourier series problems. And cos n pi is minus 1 power n. That's it. So we have simplified it. Whenever we see 1 minus 1 power n, if n becomes even, it will become 1 minus 1, 0. Correct? So when n becomes odd, it will become 1 plus 1, because minus 1 power 3 means negative sign will be there. So you will get 1 plus 1, 2. 2 4s are 8. So we will get 8 by n square pi square when n is odd and 0 when n is even. So when you are writing the series, if you look at this, a0 by 2, a0 is 0. bn is 0 since the function is even. Only you have an term. Summation n is equal to 1, 3, 5. Even terms are not there because it's becoming 0. 8 by n square pi square cos n pi x by L. L is 3 by 2. What is there on this left hand side? Function f of x. That is your question. So it means you are writing a function, given function f of x, in terms of only cos. Here a0 also 0 and bn is also 0 because of even function. So this is all about arbitrary interval. So yeah. Coming to this problem, I just want you to solve it on your own. Just see this problem. 2 minus x, discontinuous interval, right? Because 0 to 4 it is 2 minus x. 4 to 8 it is x minus 6. So it starts with 0 and ends with 8. Since it starts with 0, which interval you will compare with? 0, 2l. So 0, 2l is 0, 8. In the place of 2l we have 8. Therefore l is 4. We fixed l. Please be careful when you are fixing there. Okay. Don't write l as 8, because in the previous one, it's like in this question, if I start from minus 8 and end at 8, then you will compare with minus l, l. So here starts from 0. So you will compare with 0, 2l. We have only two choices here, 0, 2l or minus l, l. Since it starts with 0, we are comparing. Hope you don't have any doubt over here. So l is 4. Now we have to check whether the function is even or odd, because that reduces our time. So my first function f1 of x is 2 minus x, and my second function is f2 of x is x minus 6. What is the procedure in the interval 0, 2l? Replace x by 2l minus x. That is, replace x by 2 into l is what? 4 minus x. So replace x by 8 minus x. That is what I am saying. Because checking procedure differs, right? In minus l, l to 0, 2l. This is checking procedure in 0, 2l. So I am replacing x by 2l minus x. If it's pi, what I will write? 0 to 2 pi. You will write 2 pi minus x, right? In the place of pi, we have l. L in this problem is 4. So 2 into 4 minus x, that's 8 minus x. I am going to replace x by 8 minus x in my first function, and I will check whether we are getting the second function or not. So 2 minus, in the place of x I have written 8 minus x. So 2 minus 8 is minus 6. This minus and this minus will become plus. Great. X minus 6. Minus 6 plus x is same as x minus 6, which is my second function. Therefore the function is even. So the great thing is no need to find Bn because we know if the function is even, Bn is 0. So I'm just going to give only the formula. I want you to try it on your own. Since the function is even, we'll write 2 by L, only one half of the interval, 0 to L f of x dx. So what is 0 to L in this interval? And if you check the problem here, again coming back to the problem, 0 comma L, in the place of 0 comma L, 0 is here, L is there. In the place of 0 comma L, the function is 2 minus x. I am not going to write this at all. I will not use it at all. So in the place of this we have 2 minus x. So we are replacing 2 by 4, 2 minus x dx. 0 to L. What is L? L is 4. 0 to 4. 2 by L. 2 by 4, 0 to 4, 2 minus x dx. Why we have written 2 minus x? Because of this interval. The interval is 0 to L. L is 4. 0 to 4. There are two intervals given. Write the corresponding function over here. And simple integration. And we got a naught as 0 and a1 formula is 2 by L integral 0 to L f of x cos n pi x by L. So in the place of f of x we have 2 minus x, and further simplification we get answer as an. So this is your an, 8 by n square pi square into 1 minus minus 1 per n. So just we have to substitute an value in the given function. Hope you can solve it on your own. Try to solve it carefully and practice more problems to get an idea about it. Thank you.